I'm Wilfred Justin from Amazon Web Services. And I was sitting there and counting the number of times AI and machine learning was repeated in the panel and the keynotes. It was more than 130 plus times, right? So in my talk, I'm going to cover 3 different topics. I'm just going to talk about the drivers behind the wide adoption of AI and ML in the industry. And then second, we are going to talk about how AWS is democratizing AI. And the third, we are going to talk about how we can work together. I think there are a lot of folks from agencies, a lot of SAP partners and technology and consulting partners. I really want to discuss how we can work together to leverage this amazing technology to build better services to the citizens. I don't think we'll have enough time for that. I heard a lot of interesting questions and challenging questions. I'll be more than happy to discuss during the lunch break so that we can really brainstorm on particular use case whether AI would be the good fit or not, right? With that said, let's start with the drivers, right? We all agree that artificial intelligence has become ubiquitous. Think about any industry, starting from defense, space research, healthcare, finance, robotics. We can go on, right? Every single industry has been transformed or is being transformed by AI. And not only that, companies of all sizes, small, big, and large, they are able to leverage AI and reinvent themselves. But if you think from a technical perspective, we have been working on machine learning for more than 50 years. And even within AI, there is machine learning, there is deep learning, and even deep learning, which comes into neural networks. Neural networks algorithms have been in existence for 10 years. So why we are seeing the tipping point right now? And if you think about it, there are actually a couple of drivers. Again, the first driver is big data. We had a lot of interesting conversation about big data. But the point being, it's a data-driven intelligence, so we have to collect massive amounts of data, right? It's not even terabytes, it's all petabytes and more than that. And we have to collect the data from both structured and unstructured sources. And before we can make well-informed decisions, we have to go through this, we have to mine this humongous amount of data, and we can provide some kind of intelligence based on which people can take decisions, right? So 10 years back, it was a challenge. But right now, it is not, right? We are able to collect massive amounts of data in real time and batch mode. We have technologies, both in open source and from cloud computing providers like AWS. And we can store them securely with probably 11 nines of durability and without any concern about security. We can go deeper on that. And the beauty of it is we are able to process this data both in real time and batch mode, right? And the good thing, when it comes to big data, and machine learning, right? Machine learning is really all the algorithms. We don't have time to get into the algorithms, but all the algorithms are hungry for big data. So now that we're able to ingest data, normalize data, prep the data, the machine learning algorithms can consume it. So that is the first driver. The second driver is obviously things that are happening at the hardware, innovation that is happening at the hardware level, right? Probably 10 years back, we didn't have GPUs. And once again, if you look into the machine learning algorithms, they are massively parallel. So you can exploit and take advantage of the innovation that is happening at the hardware level. And the third thing is absolutely the innovations that keeps happening at the software level, which is improved techniques, better models, more tools, and frameworks. I'm not sure how many of you are really using machine learning and AI, but whenever we talk about AI, we talk about TensorFlow. Absolutely, TensorFlow is an amazing framework. But for certain use cases, right, it could be scalability, it could be a unique computer vision model. Other frameworks like PyTorch and Apache MXNet could be a better choice, right? So innovation, people are, in the open source community, people are daily innovating and building all kinds of frameworks. Another data point is, if you think about machine learning and AI, 10 years back, if you can draw a graph between x-axis and y-axis, x is data, y is the performance of the inference. As you feed more and more data, the performance of predictions, which is called inference, increased, but it kind of plateaued after a certain time, right? It kind of plateaued. It doesn't matter how much data you feed in, it is not going to improve your performance, right? Performance or predictions. Whereas with latest techniques and neural networks, it has changed. The more data you feed in, you can really generate low latency, high accurate predictions. So these are the drivers, but one of the important drivers is cloud computing platforms like AWS, right? And during the panel discussion, somebody talked about HPC. I personally had an experience. For 5 years back, I worked with a technology partner, and we were trying to build a solution for a pharmaceutical company, right? And it was a HPC problem, and they had to run lots of simulations. They had 2 choices, right? One, to go with a supercomputer. They really wanted to build a supercomputer, which cost them $20+ million. Not only the cost, right? It took them a lot of time to build it. Alternatively, nowadays, because of cloud, people can really build a humongous cluster. You can build a cluster of 10,000 nodes of EC2 instances, right? You can all cluster them together. You can run all kinds of simulations that you want. But once you're done with the simulations and once you have the results, you can just dismantle the server, release all the resources, and stop paying for what you're not using, right? So if you think about it, it is not just the CapEx to OpEx model, but the very ability for you to instantiate really powerful servers and build virtual data centers and build really supercomputers by simply using an API. That is pretty amazing, right? That is driving the innovation. So cloud computing platforms like AWS has also been instrumental in this transformation, including big data and AI. So most of you guys, I think, you know AWS. I assume that you're all working with AWS platform. So we have been providing this platform, and we have been constantly innovating on behalf of customers. But when it comes to machine learning and AI, we have extensive experience, right? We have been working on it for more than a decade, and 15 years plus. And I strongly recommend, if you have time, go and check out the keynote of Jeff Wilke, who is our CEO of Amazon at Remars. He gives amazing examples on how machine learning and AI is being used. It was used 5 years back, and how we are planning to use AI in the future, right? So our goal is, based on what we have learned and what we have built, we want to democratize AI. So at AWS, our mission is to put machine learning in the hands of every single developer. So what it means, I'm not sure how many of you are data scientists, how many of you are developers, but whether you're an expert machine practitioner or a data scientist, or you could be just an application programmer like me. You might be very good in Java and C++, but you may not have a lot of machine learning background. Irrespective of your background, the goal of AWS is we want to make it really simple and easy for anyone to build sophisticated applications based on machine learning and AI. So how do we do that? Again, I'm not going to talk about the tool. It's not a tool. It's not a toolkit. It's a platform. And to be honest with you, myself and my team, we lead at least 1 to 2 day workshops to drill into different components and talk about it and make you feel and touch this platform. But given the time constraint, I'm just going to tell the very high-level value prop of the platform, right? So when it comes to AWS machine learning stack, it comes with 3 different layers. The bottommost layer, as you can see, is the machine learning framework and infrastructure. This is for a few expert practitioners, right? When you think about demand and supply, there are very few expert practitioners. When I say expert machine learning practitioners, it means that those are the guys who are extremely comfortable in choosing a framework, not only choosing the framework, but they're optimizing the framework. They can optimize the different machine learning algorithms. They are fine with hyperparameter tuning and all those good stuff, right? So for those kind of machine learning experts, what do they look for? They look for 3 things, right? Number 1, performance. Number 2, flexibility. And number 3, cost optimization, right? So for those kind of machine learning experts, that's what exactly we provide. When it comes to flexibility, unlike other cloud providers, you can see the frameworks, TensorFlow, PyTorch, MXNet, those are the few. We support multiple frameworks rather than taking an approach of just sticking on with one framework. And when I say that, we can go a deep dive discussion on that. We optimize it once. It runs probably 2 times faster on AWS than any other platform. So that is flexibility. When it comes to performance, so you have the algorithm, you have the data, you have large amounts of data. So we need really powerful servers to process those data, right? This is where, again, I'm assuming that you know what is an instance type, an instance family. We have a lot of instances, like C5s, R5s, and P3DNs. But just to drive the point, right? One particular server is called, we released a P3DN last year. Think about it, right? The P3DN 24 extra large comes with 96 Intel Skylake vCPUs. It comes with 100 gigabits of networking bandwidth. It comes with 8 Tesla GPUs. And we can go on and on, right? So you're able to invoke that kind of powerful server with close to 1 terabyte of RAM and 1.8 terabytes of instant storage for your machine learning purposes, right? That's what they love. Using a simple API, you can instantiate that kind of powerful service. So that is when it comes to performance, we offer much more than that and much more than that. But the third point is cost optimization, right? So when the machine learning experts, when they are trying to build very flexible and high-performant application, they also want to reduce the cost. And this is where we can get into a little bit technical. I'm not keeping it technical, but that's where we released what is known as Amazon EI. So if you have dealt with machine learning applications and productions, there are two things, right? We talked about GPUs, how you can exploit GPUs, because they're all massively parallel algorithms. But when you're deploying a machine learning application, one is training and tuning the model, and then you're putting the model in production where it starts generating inference. So the process of inference it is not multi-threaded. It acts with one single data point. So when you're using a really powerful GPU, oftentimes you end up underutilizing the GPU, which translates into cost. So in order to address that particular issue, we came up with what is known as elastic inference. From a 10,000 feet, what it means is, depending on the framework, depending on the use case, and depending on most importantly, depending on the data set, you can choose the right instance type, right? You could even choose C5s or R5s, but you can burst and use the appropriate amount of GPU that you want, right? You can accelerate the GPU cycles. That is pretty amazing when it comes to cost savings, and we have a lot of industry studies where big companies, Fortune 500 companies, have saved literally 75% of their cost when it comes to deploying their application into production. So let's leave there and go one layer up. And the layer above that is called machine learning services. And most of the customers, technology partners, and consulting partners that I deal with, we talk about this service called SageMaker. Because we have very few expert machine learning practitioners, but most of the problems, most of the use cases, we need to build custom model, right? And if you have built machine learning models, it takes a lot of energy and time, right, when it comes to the infrastructure, right? So think about it, right? When you want to build a model, you have to start with the data. So if you're using a service like SageMaker, it is abstracting all the complexity of dealing with the infrastructure when it comes to building, tuning, testing, and deploying a model. It is as simple as that, right? So all your data could be in S3, but again, I'm talking about machine learning stack, but machine learning stack is just only one piece of the AWS platform. So even if we talk about data coming from different sources, your data may not be in S3. It might be in different kind of databases. It can be on RDS. It could be on DynamoDB, or it could be in somewhere, right? So we have tools as part of the platform, like Glue and other tools, where we can extract, transform, do the data cleansing, curation, normalization, and stuff like that, and make it consumable for the machine learning algorithms. And absolutely, I'm not sure how many of you use Jupyter Notebooks, so it comes with pre-installed Jupyter Notebooks. And the beauty of it is, as a platform, as part of the platform, we have 10+ machine learning algorithms which are optimized. Optimized in the sense it can run 10 times faster on AWS than any other platform because there is a separate team tuning that and optimizing it. And as I mentioned, you also have to select the framework. We support almost all the frameworks from TensorFlow to PyTorch and so on. When it comes to training the model, we don't have time, so we cannot digress and explain how training works. But whether you're using supervised training or unsupervised training, this is where it can become tricky. If you're not using a service like SageMaker, you have to deal with petabytes of scaling, right, behind the scenes. Suddenly, your data has to scale in terms of petabytes. You might want to scale your processing servers. So it takes a lot of effort and time to do that, whereas using SageMaker, it all happens behind the scenes, and it abstracts the complexity from you. And finally, when it comes to deployment, like SAP, most of you guys use AWS. So when it comes to deployment on production, this is where you have to really think about security, compliance, resiliency, scalability, and all those good stuff. And using SageMaker does a lot of things for you, like multi-AZ deployment, min-max parameters, auto-scaling, and stuff like that. So the point being, SageMaker is a service which abstracts a lot of complexity so that you can really build and deploy custom machine learning models. On top of that, we have AI services, artificial intelligence services. So if you think about it, you know about the deep learning armies, you know about the SageMaker, but the AI services, why do we have that? We have that because there are a lot of application developers who may not have machine learning background, number one. Number two, based on the use case, there is no need for you to build a custom model. Think about it. You want to read a huge folder of documents written in Chinese, and you want to convert into English, US English. You don't need to custom train model, but you can leverage a pre-trained model from companies like AWS and Google, right? So we have that. And third, you don't need to write millions lines of code in order to make this happen, right? You can just invoke an API endpoint, supply the input, and you can get the output. So, and again, once again, as I told you, we don't have enough time to cover that, but when you think about AI services, they are categorized into multiple things like vision, speech, and language. And there are pretty amazing use cases based on that, right? We don't need to talk about just data-driven and driving the operational efficiency. And I'll try to give you a couple of very interesting use cases as part of the presentation, as well as during the lunch break. So why AWS for machine learning? These are the differentiators when it comes to machine learning and AI. AWS offer some pretty unique value prop. One is the broadest and deepest set of machine learning services. I think we talked about it. And just to add another point to it, right, we are a company which constantly innovates on behalf of the customers. So when it comes to the machine learning stack alone, we released 200 plus features last year. We are just constantly innovating on behalf of the customers. Support for multiple frameworks. Again, that's a differentiator because companies like SAP might build a platform as a service, software as a service. So for 80% of the use cases, they might be using TensorFlow, but for a couple of other use cases, they might have the need to use other frameworks. So we want to support, from a platform perspective, multiple frameworks. Accelerate your adoption of machine learning using SageMaker. If you have heard me talking about SageMaker, I think you got the value prop. But just to give you an example, Intuit, they were literally building a computer vision model. They took 1 year worth of financial data of a customer, and they wanted to predict any kind of frauds, or they wanted to provide cost optimization advices. So it took Intuit like nearly 6 months to do this model, but once they switched to SageMaker, literally they saved 90% of the time, right? From 6 months modeling time, it went to 2 weeks or a week. So optimized for machine learning, I think I hit the point a couple of times. All the frameworks and algorithms are optimized to run much faster. But I'll just quickly hit the 2x performance increase in SageMaker, right? Because in the panel, people were talking about edge computing, right? So in this time and age, it is not all the companies are providing solutions on top of a SaaS platform or a PaaS platform. Because if you think about autonomous vehicle or edge devices, those are the devices where they have to make timely decisions, but they don't have a lot of processing power or main memory, right? So this model has to be natively optimized based on ARM processor or whatever processors they have, right? So when you're building the model on SageMaker, you can choose your target platform, and then it will do the native optimization based on the platform, and you can save, and it'll result in a lot of performance. Finally, the cost reduction. I think I hit elastic inference, so people are saving 75% of money saving on elastic inference, but when it comes to labeling, again, 1 minute description of ground truth. As a part of the platform, we have to label lots of data, right? Because all the machine learning models, when you train, it doesn't give the prediction with 99% accuracy. You have to train them. So you have to label a lot of data. And of course, you can use services like Mechanical Turk and do it cost effectively, but I deal with a lot of agencies where they cannot outsource this labeling of data to outsiders, right? Because it's sensitive. So they are using internal employees or labeling the data. And it is total waste of their time and productivity, right? So what SageMaker does is, based on what humans have labeled, it can quickly build a model, and it can automate the task of labeling the data so that supervised learning can start generating predictions. So that, again, it can generate a lot of cost savings. So I can go on and on, but based on these points, the point being, more machine learning happens on AWS than anywhere else. And I'm just going to quickly go through the slides. You can read it. We have so many logos, both from commercial and public sector. But the point being, TensorFlow. Most of the people use TensorFlow, but 85% of the TensorFlow workloads that runs on the cloud runs on AWS. We have twice the more customer references than most of the vendors. And we have 10,000 plus customers. So which means, I want to make that point pretty clear. There's 10,000 plus customers just using Amazon machine learning stack. We have more than 1 million plus customers using Amazon platform. So with that said, how many minutes do we have, Jason?
7 over.
Okay. So public sector, this is where I want to talk, right? So we just digressed a little bit and talked about whether AI can really add value or not. Since we don't have time, I'll reserve it for lunch break discussion. But I just want to give you a quick example, right? It's not all about cost saving. It is not all about driving the efficiency, right? AI is an amazing technology that can really make difference in people's life, and it can be deployed for a human cause, social cause, right? So in that aspect, I just want to pick up a couple of things, but because of the time, I'm just going to talk about Thorn and Marinus Analytics. I was fortunate to work with Thorn through a technology partner when they started 6 years back. Thorn was funded by Ashton Kutcher and Demi Moore. So they are digital defenders of children. I think you cannot read it, right? So what they do is they scan through the web, go through hundreds and millions of ads, apply NLU and NLP, and they can understand the intent of the ad and prevent child trafficking, sex trafficking. They can proactively inform the law enforcement agency before things happen, and they can take down the ads, right? So that's a good cause. And there are tons of examples where we can really apply AI for those kind of stuff. The other one is Marinus Analytics. It is taking the similar approach, right? It's all fighting, using AI to fight against human trafficking, but it uses SageMaker, and it can consume the camera feeds from traffic cameras, understand the pattern, and it can inform the law enforcement officers, right? So I just want you guys to take a look at the slide, and this is where probably this can form the basis of our discussion during lunch break, right? So when I was asked to do this presentation, it took me literally 10 minutes and 34 different use cases where AI and machine learning can be applied. So I think for every single agency that you're working with, or you might be a technology partner, forget the platform, forget the tool set, forget whether SAP is doing it or AWS. The call to action is think about a big problem that we can solve and reach out to us, and we can brainstorm on how we can solve that using machine learning techniques, right? I hope I had time to go through multiple things, but you will have the slides, and you can go through it. I think I'll finish it right on time. And one small disclaimer, the goal of AI is to augment humans, not to replace them, right? And the disclaimer is, it is my personal opinion, so all the video that I'm using is mine. It is not from AWS. So AI is a great technology, and absolutely it is much better than humans when it comes to certain use cases. And this video will drive the point. It is exactly 1 minute. Can you play the video?
When in transit and forward flight, and safe when approaching the ground. When in the air, the drones seem to be able to identify static and moving objects that are coming from any angle or direction. We employ sensor and algorithm technologies such as multi-view stereo vision to detect static objects like a chimney or a construction crane. To detect moving objects like a paraglider or a helicopter, we use a proprietary computer vision algorithm. Let me show you. This video from one of our many data collection flights shows what our sensing system sees when en route to a delivery. It's really hard for humans to see, but there's a moving object on the horizon. Anybody see it? Now let me show you the same video, but with an overlay of our computer vision algorithm. The algorithm detects the paraglider almost immediately. This is one of the vision tasks that computers are way better at than humans. After safely arriving over the target.
So the point being, AI is awesome when it comes to certain use cases, but human brain is unique with its own intuitions and capabilities, right? So I'm going to play a 30-second video. Can you play the video, please?
2、1，开始。
Quite a feat. He solved his 3 Rubik cubes with his feet and 2 hands, right? I'm not sure how supercomputers or machine learning can solve this. Absolutely, it can solve it, right? But one last data point. Let's assume that, this is why I'm giving a disclaimer, because it's not from Amazon. Let's assume that a supercomputer can do that, right? But think about how many operations it can do. It can do probably 93,000 trillion operations per second. Whereas human brain can do 1 million trillion operations per second using 20 watts versus 10 million watts. So there is a long way to go. And the point I do this slide all the time is, I've started hearing from not laymen, but eminent personalities, right? They talk about AI as an evil technology, and they say that AI could be the end of the human being. Personally, I don't believe in that, because after all, we were the guys who invented machine learning and deep learning algorithms, and I strongly believe that humans will enforce ethics and boundaries and use this technology for good of the mankind. So with that, I'm open for any kind of discussions. I don't think we have time now, but if you have any questions or brainstorming sessions, we can talk during the lunch break. Thank you again.